Okay, let's do the 22nd. Okay, that is limit tan 2x upon x minus pi by 2, whereas x approaches pi by 2. Now we see, as you apply the value of pi by 2 to the function, you get 0 upon 0, which is indeterminate form. Okay, so we have to change this function so that we can solve and find the limit by using the theorems. Okay, so we have two methods, so we'll look into both the methods. Okay, now you see, when you look at this resembles a theorem. Tan, we have a theorem which has tan x, so that is tan x upon x is equal to 1. Okay, where limit of x approaches 0. See, we have a theorem based on tan. Okay, tan x. So let's try to convert this to this form so that we can solve and find the limit. Now you see, now let's assume the denominator to be some other variable. Okay, so let x minus pi by 2 is equal to y. Okay, so which implies that x is equal to y plus pi by 2. Now replacing the denominator and x, we get, see, limit tan, so instead of x we will replace this. Okay, because x is equal to y plus pi by 2, so 2 multiplied by y plus pi by 2 all divided by, now x can be replaced by y. Okay, now since it's y variable, we have to replace the limit, okay, also to y. Now see, it's x tends to pi by 2, so how we get the limit for limit of y? That is, we have assumed x minus y is equal to y, x minus pi by 2 to y. So let's, as x is approaching pi by 2, let's put pi by 2 to pi by 2 instead of x, and you will get both the pi by 2 will be get cancelled, and we get 0 equal to pi. That is, y tends to 0. So the limit is y tends to 0. Okay, so now let's multiply 2. Okay, so it becomes tan 2y plus 2 into pi by 2 will become pi, all divided by y. Limit y tends to 0. Okay, now we can write this as tan pi plus 2y 1y, and limit y tends to 0. So you know that tan pi plus theta is equal to tan theta. You see, this is 0, this is pi by 2, this is pi, this is 3 pi by 2. Okay, so pi plus theta comes at the third quadrant, where tan is positive, and the function also doesn't change, tan has tan. So you can write tan pi plus theta is equal to tan theta. So tan pi plus 2y can be written as tan 2y. Okay, so we get tan 2y upon y, limit y tends to 0. Okay, so now you see, this has almost resembles a theorem, only the thing not available is 2 here. Okay, so let's multiply and divide this by 2, so we get 2 multiplied and 2 divided. Now let's write it as 2y upon 2y multiplied by, let's multiply and reciprocal, 2 by 1, and limit y tends to 0. Now let's bring the 2 out of the limit, so it becomes 2 limit y tends to 0 tan 2y upon 2y. Now see, this resembles the exact theorem. Okay, applying the value of y, you get it's 0.0, which is 1. So you will get 2 multiplied by this whole thing becomes 1, which is equal to 2. Okay, so this is the answer. Now we'll do the next method. Now let's take this in the second method. Let's take the LCM of this, okay, of the denominator. So it becomes tan 2x upon 2, so 2x minus pi, okay, and limit x tends to pi by 2. Okay, so now see tan 2x, you see tan 2x can be written as you see tan pi minus theta is equal to pi. This is 0, this is pi by 2, this is pi, and this is 3 pi by 2. Okay, so pi minus goes here to second quadrant where tan is negative, so you will get pi minus theta is equal to minus tan theta. Okay, pi minus theta will be here in the second quadrant, which will be minus tan theta. Okay, this can also, when you bring the minus to the other side, you can get minus tan pi minus theta is equal to tan theta. Okay, so instead of theta we will take 2x as an angle, okay, as theta. So minus tan pi minus 2x is equal to tan 2x. Okay, so now instead of this 2x we'll write minus tan pi minus 2x. So this will be limit x tends to pi by 2. So instead of tan 2x we write minus tan pi minus 2x whole divided by, this can be written as 2x minus pi multiplied by the reciprocal of the 2 by 1. Okay, now bringing the 2 out of the limit, it will be limit x tends to pi by 2 minus tan pi minus 2x whole divided by, this can be written as minus pi plus 2x. If you take the LCM of this, it can be written as minus pi minus 2x. Okay, minus is common, minus tan pi minus 2x. Okay, limit pi by limit x tends to pi by 2 multiplied by 2 also. Now you see this both get cancelled. Now this resembles the theorem, that is limit x tends to pi by 2 tan pi minus 2x on pi minus 2x 2 multiply. Okay, so now this resembles the theorem. So by applying the values of x, this will be 0 0, which is 1. Okay, so we'll get 2 multiplied by 1, which is equal to 2. That's it. This is the answer.